Hello everyone, welcome to this lecture, which is lecture number 4, and we are going to be talking about the 8086 microprocessor stack. So what is stack? Stack is a temporary storage, or we can say it's a part of the memory which is used in order to store the temporary data during executing a program. While a program is executed and it's going to be interrupted, some data related to this program must be stored somewhere, so that place is going to be the stack. And also this stack has one point of access. That means you can access the data, or you can send data to this stack in only one point, in only somewhere, which is going to be the top of the stack. So as you may know that the stack is going to be operated as last in first out, or first in last out. That means the data which is going to be sent to the stack last is going to be the first data to be taken back from the stack. So those those elements which you are going to send the data to, or get the data from the stack, are going to be those two operations. They are push and pop operations. When you want to send a data or an element to the stack, you need to use push operation. And otherwise, when you want to get a data back from the stack, or you want to retrieve a data from the stack, you need to use pop operation. In this graph, we can explain what is stack. So stack is only a memory, only a part of the memory, and it consists of some memory locations. And at the beginning, the original stack pointer is going to be at the top of the stack, but we have pushed this data and that one and that one, and we got here. Now the stack pointer is going to be there. We haven't pushed any other data, so they are going to be free. So this is going to be the decreasing of memory location. For example, if this memory location is 10, this is going to be 9 and 8, 7, 6, 5 and 4 and 3 and so on. And when you want to pop a data, when you want to get a data out from the stack, so this stack pointer is going to be increased. But while we are sending a data to the stack pointer is going to be decreased. So in order to access the stack, we need to use two registers. One of them is going to be the segment register, and we know that that segment register which is pointing to the stack is going to be the stack segment register, and that stack segment register points to the first memory location of the stack segment inside the RAM. And the stack pointer is going to be use an offset as an offset in order to to access the other memory locations belongs to the stack. So the stack pointer always points to the top of the stack. Why? Because we can only send the data to the stack while we are in the top of the stack, or to the top of the stack, and we can get the data which is from the top of the stack. So the stack pointer always points to the top of the stack. So as we said before, stack pointer decreases as data is pushed. When you send the data to the stack using the push operation, the stack pointer is going to be decreased. So in this case, when we send a data which is going to be 16 bits, and we know that each memory location can hold only 8 bits, so the stack pointer is going to be eliminated by 2, then the data is going to be stored in that memory location, this which is expressed in logical address. This is going to be the stack segment, and this is the stack pointer. So the content of the AL is going to be stored in first memory location, and the AHI in the next memory location. And while we are popping a data, we are getting a data out from the stack. For example, pop AX. That means go to the stack and get the data back from the stack and store it inside the AX. In this time, the data is going to be popped out, then the stack pointer is going to be added to 2, because we have taken 2 data out from the what is called the top of the stack. But we can use even base pointer to the stack to point any element inside the stack. So, but when we are using stack pointer, we can get that element which is from the top of the stack, or store the data, or store that element to somewhere which is the top of the stack. But here we can send the data to anywhere inside the stack. Okay, when you are pushing a data, how does it work? How it occurs? So when you say push, it pushes the operand into the top of the stack. Which operand? That operand which is specified in the instruction. When you say push BX, the data inside the BX is going to be stored inside the stack. But how? First, we know that the value of the stack segment is not going to be changed. So the start pointer is going to be decremented by 1, and then the b high is going to be stored there. And it's going to be decremented by 2, and the BL is going to be stored there. So first, b high going to be stored, and then BL. So after the push operation, what happens? The stack pointer is going to be stack pointer -2, the old one -2. So it's going to be updated with this one. So let's take this example. Let bx equals to 6ab3, and before push operation, stack pointer is this value and the stack segment is this value. So the memory address, which is going to be the physical address, is going to be calculated using our methods, which we have already talked about that, but after shifting the segment value by 1 hexadecimal digit and add it to the offset, which is the stack pointer. So in this case, the stack pointer points to this memory location, but it's going to be decremented by 1, then the b high is going to be stored. So 037FF, which is this one decremented by 1, 6A is going to be stored there, and 037FE, which is decremented the original one by 2, and the below is going to be stored there. And after the push operation, the stack pointer is going to be pointing to the original stack pointer -2, which is going to be this memory location. So this is the explanation of the previous example. We have bx, which contains this value, and this is the stack pointer, and this is the stack segment, which points to the first memory location after shifting it 1 hexadecimal digit to the left. And when we add it with the stack pointer, it's going to be that memory location. That means before pushing the value, the stack pointer is located here. But what happens after pushing it? So after pushing it, we say push bx. This one, 6a, which is inside the b high, is going to be stored inside the stack pointer -1, and b3 is going to be stored in the stack pointer -2. So after the push operation, the stack pointer is going to be decreased by 2 memory locations. So it's going to be located here. So how does the pop is going to be executed? So the pop performs the inverse operation of the push. That means pop gets the data out from the stack and and place it inside that register or that parameter, which we are going to be using it with the pop operation. So when you say pop bx, the content of this memory location, the stack segment and the stack pointer, which is the top of the stack, is going to be stored in BL, and the next memory location is going to be stored inside the B high. So after the pop operation, the stack pointer is going to be increased by 2. This is the original one, and this is for the next memory location, for the next data, and after executing this one, again, it's going to be incremented by 1 as well. Let's say this example. So the stack pointer is this value and the stack segment is this value. So stack segment and stack pointer, which is expressed in logical address, is containing 2f, and stack segment, stack pointer +1 is going to be having this value. Let's say they are inside the stack. When you say pop bx, the first data, which is contained in here in the stack pointer, is going to be stored inside the BL, and the next data is going to be stored inside b high, which is 39, and then the this is going to be 1006, and this is going to be 1007, and again the stack pointer is going to be incremented by 1, which is going to be 0108. Actually, I forgot a 0 here. It is going to be 1008. So here is the graphical representation. According to those values here, the stack pointer is going to be pointing to this memory location, right? This one is shifted and added to that one, we'll get that one. And when you say pop bx, this 2f is going to be stored inside the BL, and it's going to be incremented by 1, the stack pointer. The 39 is going to be stored inside the b high, and then again the stack pointer is going to be incremented by 1, and then this is going to be the top of the stack. And thanks for everything, and I will see you in the next lecture.